We are tracking an escalation in transportation technology that begins with a $150,000 flying car and ends with a $10 million concept vehicle that reacts to your touch like a creature. These machines are designed to solve this reality. Every year, commuters spend hundreds of hours trapped in a grid of red and white lights. Standard cars are restricted by a two-dimensional grid. They are bound by friction, traffic laws, and the rigid layouts of city streets that dictate every turn. To escape these constraints, engineers are building vehicles that break specific physical barriers. We are analyzing each tier of this technology to see what it costs to buy your way out of the 2D plane. Solving the modern commute requires moving beyond the pavement and abandoning the two-dimensional grid entirely. The first tier of innovation costs $150,000. This is the NEC flying car, seen here suspended for testing. It turns the morning drive into a contest between traditional roads and open airspace. The primary advantage is routing. A driver on the ground obeys stop signs and follows coastlines, but a pilot can maintain a direct, linear path across the water. Traveling as a linear vector eliminates the extra distance required by a city red. By cutting across a body of water instead of driving around it, a commute can be cut in half. At the $500,000 mark, we find the personal jetpack. This is the JB-11, which reaches 80 miles per hour and provides a 3-mile flight range. It uses 6 small turbojet engines to generate the thrust needed for vertical takeoff, allowing high-speed travel that isn't dependent on any existing infrastructure. This first tier of wealth proves that the ultimate luxury is bypassing the ground to buy back lost time. Engineering breakthroughs continue on the ground for those willing to pay a $1 million price tag for a car that defies gravity. This diagram shows inverted driving physics. High-speed fans create massive upward suction, pulling the vehicle's weight against gravity. But suction isn't enough. On this velocity threshold graph, the car must maintain high forward speed, keeping aerodynamic pressure high enough to prevent falling. While the car handles the physics, the driver experiences severe physiological strain. Driving upside down forces the blood in the body to rush toward the head, causing intense pressure and discomfort. At this $1 million mark, engineers are forcing metal to stay where it shouldn't, overcoming gravity at a heavy physical cost to the driver. Finally, we reach the $10 million Mercedes concept car. Inspired by Pandora, its design focuses on a biological aesthetic rather than raw performance. At 10 times the cost of the inverted car, the goal shifts toward the chassis itself. It is designed to act as a reactive creature that physically responds to human touch. The interior eliminates the steering wheel. Instead, the driver uses a central pad that they press forward to move and twist to change direction. This mechanical interface allows for movement that standard cars can't replicate. The wheels can rotate 90 degrees, allowing the vehicle to move sideways to navigate tight spaces. The cabin is integrated with biometric sensors. The seats monitor the driver's heart rate and vitals to automatically adjust the temperature and airflow of the interior environment. This tier prioritizes turning the car into a responsive extension of the driver, integrating biological monitoring with mechanical movement. Progress in transportation is currently defined by breaking physical rules, moving from simple optimization to entirely new ways of interacting with the world. The $15,000 tier changes the routing of our travel. The $1 million tier changes the orientation of our travel. And the $10 million tier changes how the vehicle monitors the passenger. Using a vehicle that reads a human pulse to adjust its own internal systems changes the relationship between the machine and the operator. If you want to see more tests of futuristic technology and the limits of engineering, hit the subscribe button. We are reaching a point where the vehicle reacts to the driver's biological state as much as their mechanical input.